Okay, hello everyone. So this is part 2 of our series on trigonometric integrals. In this video, we're going to discuss how to solve integrals of the form tangent raised to nx times secant raised to mx. For us to start our discussion, let us recall this consequence of the Pythagorean identity. Secant squared x equal to tangent squared x plus 1. Or tangent squared x equals secant squared x minus 1. Okay, so these are just consequences of the Pythagorean identity. Sine squared x plus cosine squared x equals 1. We again divide it into three cases. So case 1, if the power of secant is even and it is at least 2. Okay, we either rewrite it as a product of secant squared x and secant raised to m minus 2x, or make the substitution u equal to tangent x. Case 2, if n is odd and m is at least 1, we rewrite tangent raised to nx times secant raised to mx as tangent raised to n minus 1 times secant raised to m minus 1x times secant x tangent x. Basically, ang ginawa natin, nag-factor out tayo ng secant x tangent x. Okay? Or And then we make the substitution u equal to C3. If n is even and m is odd, we use tangent squared x equal to secant squared x minus 1 for us to be able to write it as powers of secant x. Alright, before we proceed, let's consider these two interesting integrals. No? Alright, consider the integral of tangent x dx. Previously, wala tayong way to solve this. Pero now that we have discussed how to integrate using or integration by substitution, by some simple manipulation, that is, si tangent x isulat natin as sine x over cosine x dx. Okay? Now, since we have this, we can consider this as let u be equal to cosine x. So that would mean that the derivative of u with respect to x is negative sine x dx. So we are now able to rewrite this as the integral of negative du over u, or negative ln ng absolute value of u plus c. Now, applying the substitution again, this is negative ln of the absolute value of cosine x plus c, or in some cases, this is considered as ln of secant x plus c. Okay? Now, the same approach is done kapag ang gusto naman natin is yung integral ng cotangent x dx. So, I'll leave this to you as an exercise. All you have to do is write this as a ratio cosine x over sine x. Okay, now the next integral, this is a bit more complicated. So we have the integral of secant x dx. Okay, in order for us to solve this, we can actually multiply this by 1. Pero yung 1 is written in another form. So we're going to multiply it by secant x plus tangent x all over secant x plus tangent x. So again, this is the same as multiplying it by 1. I simplify. We have secant squared x plus secant x tangent x all over secant x plus tangent x dx. Okay, from here, notice that we have secant squared x plus secant x tangent x sa numerator. Okay? Now, if we consider our u to be the entire denominator, so let u be equal to secant x plus tangent x. Getting the derivative of u with respect to x will actually give us secant x tangent x plus secant squared x dx, of course. So we have written this as the integral of du over u. Okay? So after applying the substitution, we will get this is equal to ln ng absolute value of u plus c, or ln ng absolute value of secant x plus tangent x plus c. Okay, these two integrals may be used in solving uh, this type of trigonometric integral. Okay, so let's proceed by solving a few examples. Okay, first example we have is the integral of secant to the fifth x times tangent x dx. Okay, this case falls under case 2. Okay, so what we do is we separate a factor of secant x times tangent x, which we can easily do. So we just rewrite this as secant x times tangent x times yung natira natin, secant to the fourth x dx. Okay, then we make this substitution. Let u be equal to secant x. It would follow that du is equal to secant x tangent x dx. So we are now able to rewrite this as the integral ng u to the fourth du. Applying the power rule, this is u to the fifth over 5 plus c. And then we just rewrite it in terms of x. So this is secant to the fifth x all over 5 plus c. Okay, now the second example, we simply have to make the substitution. So let u be equal to tangent x. So doing this will give us du equal to secant squared x. So medyo straightforward siya that this is actually equal to u to the fifth du. So applying the power rule, this is u to the 6 over 6 plus c, or tangent to the 6x all over 6 plus c. Okay, so we still have to examine, no, kung mas madali ba kung magsa-substitution na lang tayo. Okay, for instance, we have this, the integral of tangent to the 6x times secant to the fourth x dx. Okay, this falls under case 1. Falls under case 1, wherein we're going to separate a factor of secant squared. So, tangent to the 6x times secant squared x times secant squared x dx. this part here, we rewrite this as 1 plus tangent squared x and simplify. So we have tangent to the 6x plus tangent to the 8x times secant squared x dx. From here, we proceed by making the substitution. Let u be equal to tangent x. So du natin ay secant squared x dx. Oops, sorry, this should be dx. So we are now able to rewrite this as the integral ng u to the 6 plus u to the 8 du. Applying the power rule, we have u to the 7 over 7 plus u to the 9th over 9 plus c, and rewrite this in terms of x. Since u is equal to tangent x, so this is tangent to the 7th x all over 7 plus tangent to the 9th x all over 9 plus c. Okay, now for our last example, we have this one, the integral of tangent to the 5th x times secant cube x dx. Okay, this falls under case 2 again. So what we do is we separate a factor of secant x times tangent x. Okay, so secant x, tangent x, and then we're left with tangent to the 4th x, secant squared x dx. Okay? And then, since may natira sa atin na tangent to the 4th x, what we do is we rewrite this as tangent squared x squared, or secant squared x minus 1 squared. Okay, doing so will give us, okay, secant x times tangent x times secant squared x minus 1 squared times secant squared x dx. From here, we can already make the substitution. So let u be equal to secant x. This would mean that du is secant x tangent x dx. So we can rewrite the integral as u squared minus 1 squared times u squared du. I simplify. This part here will give us u to the 4th minus 2u squared plus 1 times u squared du, or u to the 6th minus 2u to the 4th plus u squared du. Applying the power rule, u to the 7th over 7 minus 2 to the 5th minus 2 fifth u to the 5th plus u cube over 3 plus c. And then the last step is for us to rewrite this in terms of x. Since u is equal to secant x, so this one is secant to the 7th x all over 7 minus 2 over 5 secant to the 5th x plus secant cube x all over 3 plus c. Okay, this ends the video or the part 2 of our series of videos for trigonometric integrals.